Welcome. I'm Ramya Devi, working as assistant professor in computer science and engineering department. In this video, we're going to see genetic algorithms. So, genetic algorithm is an adaptive heuristic search algorithm which is used to solve optimization problems. So, in this video, we'll be seeing a sample genetic algorithm, and 8 queens problem will be solved with the help of genetic algorithms. So, this is actually a flowchart of genetic algorithm where it has 5 phases to solve the complex optimization problems. The first phase is an initialization. So, generate in the first phase, we'll be generating initial random population of candidate solutions. These solutions will be representing either chromosomes or an individual. So, second phase is an fitness assignment. So fitness will be calculated. We'll calculate the fitness of each individuals in the population using a fitness function. Third phase is a selection. We'll be selecting individuals from the current population based upon the fitness scores. So individuals with higher fitness will be more likely to be selected. So there are different methods to select individuals, either using rank-based selection, tournament selection, wheel selection, etc. And the fourth one is reproduction. Fourth phase is a reproduction where we'll be using generating genetic operators like crossover or mutation. So, crossover will be extracting genetic information from parents to produce new individuals, whereas mutation, it will be introducing some random changes. So, all these steps will be getting repeated. The fifth one is the termination. All these steps will be repeated until the termination condition is met. If the condition met, the algorithm will be stopping. So, this is actually the pseudocode where genetic algorithm will be taking two inputs. One is the population, a set of individuals, and the second one is fitness function that measures the fitness of an individual. So we are going to start the algorithm here, and this gets repeated until the termination condition is met. So we are going to create an empty set and it will be assigned to the new population. So this loop will be iterated over the population in order to select the parents x and y. So x will be selected based upon from the current population based upon random selection using the fitness function. So the same happens for y. Once x and y are selected, the child will be produced with the help of reproduce function by passing the two parameters to parents x and y. So if the random probability of the child is small, then mutation will be performed. If not, the child will be added to the new population. So the new population becomes the current population for the next iteration. So this gets repeated until the either of two condition is met. When an individual in the population matches the fitness function or when a predefined time limit has been reached. Genetic algorithms reproduce function where reproduce, it takes two, as I said before, it takes two parents x and y and it produces an individual. So for that, first we'll be calculating the length of x and it will be assigned to n. And a random number between 1 to n will be generated and it will be saved inside C. C will be acting as a crossover point. So the two strings will be extracted. Genetic information will be extracted from both the parents x and y. So from x, from the beginning till the crossover point will be extracted. And the second part will be extracted from y from C plus 1th position till the end of the string. Then it will be appended, concatenated with the help of an append function. So that new child will be created and it will be returned. So 8 queens problem is nothing but it is a challenge of arranging 8 queens on the chessboard in such a way that no two queens pose a threat to one another. So solution, it requires very simple. No two queens share the same row, same column or the same diagonal. So this is a threat where two queens placed on the same diagonal. There are 92 possible solutions. One of the solution is given here. So these row represents the queen number and the column represents the queen's position. So Q0 here, Q0 is placed in the 0th position. Q1 is placed in the 4th position and Q2 it is placed in the 7th position and so on. This is the representation. There are 92 possible representations where one representation is given here. So we need to find the optimal solution using genetic algorithms. So N-Queen's problem piece framework, in which the key components like states, actions, and goal is described in this slide. So state is nothing but all possible arrangements of N-Queens, one per column in the leftmost N columns, with no attacking queens to be placed. Actions, we need to add a queen in any square in the leftmost empty column such that it should not be attacked by another queen. So the goal is very simple. We have to place all the 8 queens on the chessboard, so no 2 queens attack each other. So here, this is a Python code for implementing 8 queens problem. First, we have imported the libraries. So NumPy is imported for numerical operations as well as for array manipulations, and sys, it is for system specific parameters and functions. So initialization is done here. We have initialized the variables in order to configure the GA for solving 8 queens problem. As I said before, the number of queens is 8 and the stop criteria is given as 28. Why it is given as 28, I'll brief in the next upcoming slides. So mutation flag is set to true. It is used to represent whether the mutation is required. And the maximum iteration is given as 10,000 and the population is initialized to none. So here the chessboard position, the board position, the required board position is defined with the help of a class. It has a constructor, 3 setter methods and 1 getter method. So the data members are initialized. Sequence, fitness and survival are initialized to none. So set sequence, set fitness and set survival are used to set the values for the data members. And getter method, it returns the dictionary of values, attributes, sequence, fitness and survival. So in order to test for the conflicts, already I said we have to check for row conflicts, column conflicts and diagonal conflicts. So before checking these things, we have to find the fitness. Based upon the fitness only, we could able to determine whether the clashes are there. So fitness of an individual is attributed to the number of clashes. So in other words, fitness function is proportional to the number of clashes. So in the 0th iteration, Q0 will be placed and 7 more non-attacking queens are to be placed. Like in first iteration, Q0 and Q1 would have been placed and 6 more non-attacking queens are to be placed and so on. So if we start from 0 to 7, these are the values. When we sum up, we'll be getting the value as 28, I'm sorry. So that's why the stop criteria is given as 28. So there will be 28 clashes in 8 cross 8 chessboard. So for 8 queens, it will be 7 plus 6. When we sum up all these things, we'll be getting 28. If an individual has high fitness, it will have lower number of clashes. So therefore, the fitness value will be calculated as 28 minus number of clashes. So in order to find the row and column clashes, first we have to find the difference, the length of the difference between the two arrays. So the total length of the array from it will be subtracted with the unique length. So this represents a board configuration where each element corresponds to the column position of a queen in each row. And the second one represents a unique position where queens can be placed without any conflicts. So what is the size of the array? The size of the array is 6. Here the size of the array is 2. So 6 minus 2, it is 4. This is how we'll be finding the row and column clashes. So in the fitness function, the first one, we have to find the row and column clashes where clashes is initialized to 0. And the row column clashes will be the absolute difference between the length of the total length of the array minus unique length of the array. So once we find, that will be initialized to clashes. So we have to find diagonal clashes also. So this is for calculating the diagonal clashes. So this gets iterated over the chromosome. Chromosome is nothing but an individual. Individual is nothing but the positions. Say for example, I'll take an example for 1, 2, 3, 4, 5, 6, 7. So this is an individual. So this represents the queen's position in the chessboard. So what is the length? The length is 8. So I and J iterates over the length of the chromosome. So this condition is checked in order to ensure no queens are compared with itself. So we have to find the horizontal distance and vertical distance. So horizontal distance, we can compute horizontal difference by checking the absolute differences between the queen numbers. So I and j, it represents the queen numbers. So we have to find the differences between the queen numbers. The vertical difference is nothing but, we'll be checking the values in the it is nothing but the queen's positions. Okay, so the index will be I and j. The value in the index will be giving the positions. So where the queens are positioned. Okay. So when these two values are same, then we can say both the queens are on the same diagonal. So in that case, we have to increment the clashes value. So in the previous slide, we have calculated row column clashes. Here we have calculated diagonal clashes. Once all the clashes we have computed, we have to return. So we'll be returning as 28 minus classes, number of classes. So if an individual having a class which is equal to 28, then we can say that chromosome is we got the optimal solution. For that only we'll be calculating the fitness function. So generating chromosome, n queens is a variable which is assigned to 8 in the previous slide itself. I've shown you where n queens is assigned to 8. So in order to declare it as make it as a global one, the global keyword is used here. So np.arrange n queens, it will be generating a single dimension array of length 8 between the numbers 0 to n. So it will be having a positions. So initial positions of the queen will be generated, and it will be saved inside init underscore distribution. np.random underscore dot shuffle will be shuffling all the values. Once it is shuffled, we'll be returning the values. So the generate population which is used to generate the population. So in the if the size is given, size is passed, so population will be generated, the individuals will be generated, chromosomes will be generated to that size. If not, the default value 100 will be taken. So population, in the beginning we have initialized to none. So in order to make it as global, we have declared a global keyword. So the next one, population size, we have saved inside population. The board position we are calling the constructor. Once the constructor is called, an instance will be created. So here the population size is given. Till that an instances will be created. So 100 such instances will be created if the population size is 100, and that will be saved inside population. So again it is going to iterate over the population size. So we have to find the board position is a class which contains 3 attributes. One is sequence, the next one is fitness, and the third one is survival. So we have to calculate all these 3 things: sequence, fitness, and survival. So generate chromosome, it generates an individual. Once it is generated, it will be uh, placed inside sequence. The value will be assigned to sequence with the help of set sequence method. Again, the fitness will be calculated by calling the fitness function, and again it will be assigned to fitness with the help of setter method, fitness. So in order to find the survival, the survival will be computed based upon each fitness value divided by sum of all the fitnesses. So in order to find the sum of all the fitnesses, we have to use this method. So once we found out, it will be assigned to summation fitness. Again we are going to iterate over the population in order to find each and every individual's fitness. So fitness divided by summation fitness will be the value which will be assigned to each dot survival, and then the population will be returned. So get parent, we are going to get the parents. So parent 1 and parent 2 are initialized to none. Now we have to choose parent 1 and parent 2. So this gets iterated till we choose parent 1. np dot random dot rand will be generating a random number between 0 to 1. So once it is generated, it will be stored inside parent 1 underscore random. So we'll be checking the individual's survival value. So if the individual survival value is less than or equal to parent 1 underscore random, then the list, the individual will be added to this particular list. So out of 100 such individuals, only 30 to 40 individuals might be having that value. So one, we'll be choosing only those individuals. We'll not check for all the things. Instead, checking all the things based upon the survival, we'll be choosing the individuals. So survival is less than or equal to parent one underscore random. Those individuals will be taken and it will be assigned to parent one underscore random. So from this, the first individual will be taken and it will be assigned to parent one. So if this list is empty, again the iteration will be this gets iterated. So once we found the parent one, we can find parent two. So the parent two will be chosen in the same way. Rather, instead of selecting the first one, again a random number will be generated. So the survival value will be chosen based upon that. The individuals which are having the survival value less than or equal to parent two underscore random will be taken and it will be added to the list. So from this particular list, we'll for parent one we have taken the zeroth position. Instead of taking the zeroth position in this method, for choosing parent two, what we'll be doing is the length of the parent two will be chosen. So as I said before, 20 or 30 such individuals will be satisfying that condition. So we have to ensure we are going to choose the number between 0 to that particular number of individuals. So if we go beyond that, it will be raising an exception. In order to ensure that, first we have to find the length of the parent and length of the individuals in the parent to underscore random. Then that a random number will be generated from 0 to length of number of individuals present in parent to underscore rn. So the t will be acting as an index. So from that particular index value, whichever the individual is there, that will be assigned to parent 2. So once we find parent 1 and parent 2, we'll be checking whether parent 2 is not equal to parent 1. If so, we'll continue, or else this loop gets iterated again. So if this is true, we'll be checking whether parent 1 and parent 2 is not none. So if it is not none, we'll be returning parent 1 and parent 2. If not, the error code -1 will be returned. So reproduce crossover will be taking two parents, parent 1 and parent 2, and it will be producing a child. So for that, parent 1 dot sequence will be computed and it will be saved inside n. So we'll be generating a random number between 0 to n, and it will be saved to C. So C will be acting as a crossover point. So board position and instance should be created. So this will be having three attributes: sequence, fitness, and survival. So sequence is assigned to empty list. Then we are going to find the sequence based upon parent 1 and parent 2. From the beginning to crossover point, the string will be extracted from parent 1. From C plus 1 to the end of the list, we'll be taking from parent 2, and these two things will be appended, and that will be making as a child sequence. So once we find the sequence, we have to find the fitness. So we'll be calling the fitness function. So once we find the fitness, it will be assigned to the fitness with the help of set fitness method. Here we cannot find the survival. Why? Because the survival, it depends upon the summation of all the fitnesses. So I'm sorry. So we have to add the child to the population, then only we can able to find the survival value. So mutation, it will be checking whether the mutation is required. So this is the definition of mutation, where we'll be checking the mutate as a value which will be assigned. So this value will be checked with the child dot survival. If it is less than mutate, then we'll be mutating the child. So we'll be checking np dot random dot random. It will be generating a random number and it will be assigned to C. So then we'll be again generating a random number. Whatever the number is generated in that corresponding index point, the value will be replaced. Then the child sequence will be returned. So here, this is the genetic algorithm. It takes, we'll be passing the number of iterations where new population is an empty list. So this will be iterated till the end of the population. So we'll be calling the get parent, parent 1 and parent, it will be returning two parents, parent 1 and parent 2, it will be assigned to parent 1 and parent 2. So once parents are found, we'll be calling the reproduce underscore crossover in order to produce a child. Once the child is, as I said before, we cannot find the survival of the child while we generate the child. So we'll be appending the child to the new population. Then we'll be finding the summation fitness. So summation of all the individuals will be added together and it will be assigned to summation fitness. So based upon this value only we can find the survival. So again it will be iterated till the new population. So fitness will be calculated, the survival will be calculated by each individual fitness value divided by the summation fitness. So if mutate flag, if the mutation is required, if the mutation flag is set, then we'll be checking again. It is iterated over new population. Each and every individual sequence will be assigned to present value, and we'll be calling mutate of each. So it will be returning might be changed value. So if present value is not equal to might be changed value, then we'll be reverting back the present value and the fitness value. If not, the summation will be calculated, summation fitness will be calculated, and we'll be finding the survival for each and every individual. So stop, as I said before, there are two criteria. The stop criteria should be equal to 28. Once the individual's fitness value is equal to 28, we can stop the algorithm. Why? Because we got the optimal solution. If not, if the maximum iteration is reached, then we can stop the algorithm. So here population size is given as 100. Mutate is given as 1 divided by population size. 1 divided by 100, it is 0.01. So population, generate population, it generates a population. We are passing the population size. So population size is given as 100. So 100 such individuals will be generated and it will be saved inside population. So this is iteration 0. Iteration variable is initialized to 0, and while not stop. So this will be looped again and again until any of the two criteria is met. The first criteria, if any of the individual's fitness value is equal to 28 or the maximum criteria is reached, the maximum iteration is reached. So population GA, it calls the genetic algorithm function and algorithm gets incremented. So iteration number will be printed here. So this gets looped until we'll be until it meets the termination condition. So again, this will be looped till the population. So whichever the individual having the fitness value equal to 28, that sequence will be printed on the screen. So this is the output where in the 4310 iteration we got the optimal solution. So when we place the queens in this position, all the queens will not be in the attacking positions. This is what we found using genetic algorithm. So thank you. If you have any doubts, you can ping me at ramyadevi.cac@hiset.ac.in. Thank you.